In this video, I will teach you how to rewrite a rational expression in order to figure out discontinuities. A discontinuity is a distinct break in physical continuity of a function. For the first equation, we need to factor the denominator in order to check for common factors, and it makes it easier to read. I will use the BOT method for this. I have plugged in the information we already know. Now we need to figure out what you can multiply two numbers together to get -6 and what you can add to get x. You can multiply -2 and 3 together to get -6 and add -2x and 3x to get 1x. Now that we know the factored form, we can plug it in now. As you can see, we have a common factor at x minus 2. We have one here and here. A whole is a discontinuity in a function. So, since the whole is x minus 2, that means that if you set x minus 2 equal to 0, the whole is x equals 2. Now that we know there is a whole at x equals 2, we use this to figure out the vertical asymptote. What you do is you set this equal to 0, and you should get x equals -3. Now, to find the horizontal asymptote, you check to see if the numerator and the denominator have the same x degree. Now that the x minus 2's cancel out, it's 1 divided by x plus 3. And so that means that the denominator has a higher degree of x, which means that the horizontal asymptote would be y equals 0. Now for number 2, I will factor the denominator, which is simple. You just take out the 2. So you should get 7x divided by 2 times x minus 2.5. Now since there is no common factor, there is no whole. Again, for this one, to find the vertical asymptote, you would check the x, Now again, in order to find the vertical asymptote, you check the factor in the denominator. And since it is x minus 2.5, it would be, if you set that equal to 0, x equals 2.5. Now this one is different. Since they have the same degree of x on both the numerator and the denominator, you would check the 7 and the 2, or the first number in both of these, and you would look for 7 over 2. And that means that the horizontal asymptote would be y equals 7 over 2, or you could say 3.5. Now we're going to check the discontinuities that we got. For number 1, the whole was at 2. So on Desmos, I will check at x equals 2, and it is undefined. Now, the vertical asymptote is at x equals -3. Here it is x equals -3, and it is this green line going straight up and down. The horizontal asymptote is y equals 0. If you look at Desmos, I have it set to y equals 0 right here, and the blue line is y equals 0, and that is the horizontal asymptote. Now it will check number 2. So there is no whole, so if you were to look at the graph of 7x over 2x minus 5, there would be no whole anywhere in the function. If you look anywhere, there will be no whole. The vertical asymptote is x equals 2.5, so I set it to x equals 2.5 over here, and this is the blue line. And as you can see, this is the vertical asymptote. Since the horizontal asymptote is 7 over 2, or 3.5, I have set it on the graph to y equals 3.5, and as you can see, that is the horizontal asymptote. This is how you find discontinuities in rational expressions by rewriting them to make it easier.